Today we are talking about 9.4 properties of logarithms. Today we're going to look at expanding versus condensing logs. Now, to be transparent, in this class the only thing we'll do is we'll take the expanded form and condense it. We will never go backwards where we expand from the condensed form. If you plan to go to pre-cal next year, you will see both forms there. So we've got three properties we're looking at here. This first property, don't get too hung up on the letters. All of my examples will have numbers in it. But basically what's going on here, if you have two logs and they're being added, what you're actually going to do is multiply the two terms here, the m and the n. That's what's happening here. So it looks like addition, but it's actually multiplication. Let's do an example with actual numbers. Log base 2 of 5 plus log base 2 of 10 equals, and when we add the logs, we're actually going to multiply the numbers. So a student who has no idea what they're doing is going to write 15, but you know better. We're going to multiply log base 2 of 5 times 10, which will give us log base 2 of 50. And there you have it. Property number 2 works the same way, except with subtraction being division. So when you subtract two logs, you're actually going to divide the m and the n. Now pay close attention here. Notice that when we do this division, the m, which comes first, goes on top, and then the n comes second, that goes on bottom. The order absolutely matters there. You divide in the wrong direction, your answer will be wrong. So we'll do an example of that. Log base 3 of 20 minus log base 3 of 4. So again, we're not actually going to do 20 minus 4 and get 16. We're going to divide log base 2, and the 20 is first, so it's 20 on top divided by 4 on bottom equals log base 2. And since these are nice numbers, we can actually divide them and just get a 5. Oh, it's a 3. Hold on. This is a 3. Questions over these first two? Number 3 is my favorite property. It's a little different. So this one looks different from the other two. We have a number in front of the log. This number, if you look in the condensed form, becomes the exponent of the term here. So whenever I see this, I will circle it, and I'll draw an arrow pointing to where I'm going to place it next. So let's do that. We have 3 log base 6 of 4. So I'm going to take this 3 and I'm going to put it in its new spot. So that's where it's going to go. I'll rewrite it. Log base 6 of 4 cubed. Make sure you do 4 cubed, not 4 times 3. Log base 6, and don't just leave it. If you can figure out what that number is, go ahead and do the math. 4 cubed is 64. That's our answer. Those are the three properties explained, each one with an example. Any questions over those three before we get into a couple more rules? So when we do actual problems, we're going to use these properties to condense these down into a single log. Before we do that, I have to set two ground rules that you must follow. Rule number 1, follow PEMDAS. Reminder, PEMDAS is your order of operations. Now, luckily for us, we don't use all of these. If you look at the three properties, we have multiplication, division, and exponent. So we're only using the three letters here, E, M, and D. So those are the only three operations you have to worry about. So following the order, we must do exponents first. Once we've done the exponents, then it's the M and the D, the multiply, divide. Now, I don't know if you've had this like articulated before, but when you multiply, divide, you don't have to do them in that exact order as they are listed in the acronym. It's multiply or divide, whichever comes first. So then, multiply, and I'll write slash divide, because it just depends on which one you see first, from left to right. So first rule, follow PEMDAS, exponents, then we multiply or divide. Second rule, and this one's just as important as the first rule. So I have some of you in here who are going to want to break this rule. Please don't. Let's look at the problems real quick. Notice the first three examples all only have 2 logs, so those are manageable. The fourth example has 3 logs. When you have more than 2 logs, you have to do it in multiple steps. So, rule number 2, you can only condense 2 logs at once. If you have 3, or when we get into pre-cal, we have 4 and 5 and 6, we have a lot of logs, 2 at a time. Don't try to do them all at once. Only condense 2 logs at a time. All right, let's do some actual problems. The first couple are going to be pretty straightforward. Number 1, log base 5 of 4 plus log base 3 of 3. Log base 5 of 3, excuse me. Only thing we have going on here is this plus, which we know actually means multiply times. We have log base 5 of, I'm going to multiply 4 times 3. And actually do the math, don't leave it like that. Log base 5 of 12. Someone's going to put 7 on the test because they'll do 4 plus 3. Don't let it be you. Number 2, let's throw in some variables. log base 6 of x minus 3 plus log base 6 of x. Again, only thing we have here is this plus, which means multiply. Log base 6 of x minus 3 times x. Now this is written a bit weird. This isn't usually how we write it, but this is something we have done, it feels like, a million times this year, especially over the past month. How do I multiply this? What do I actually do? Chase? Distribute. The x is after the parentheses, that's okay. And then I have the times there. So distribute. And I'm going to distribute from the parentheses just so I put the terms in the correct order immediately. Log base 6 of x times x, that's x squared. X times negative 3, that's negative 3x. Now I do want to make a point here. I'm not going to be picky about this in Algebra 2, but future pre-cal students, I will absolutely crack down on this in pre-cal. This answer, as I have it written right now, is incorrect. You must show with parentheses that that entire thing is included with the log. If you drop those parentheses, it is absolutely a different answer. And I'd be happy to explain that further on a one-on-one basis. But if you end up with multiple terms, just put them in parentheses. Again, if you drop them in this class, I won't take off points, but higher math classes, you will lose credit for that. Just want to let y'all know. And that's our answer. Questions on 1 or 2 before we move on to 3 and 4? Number 3. Log base 5 of x minus log base 5 of x plus 2. The only thing we have here is this subtraction, which actually means division. Log base 5. And then when we divide, it's left to right. So the left term goes on top. So we have the x over the x plus 2 goes on bottom. Keep those parentheses so we don't cancel out the x's. You're not supposed to do that. And that's all we can do. That's it. That's our answer. If you can't cancel, can't reduce, then leave it. Questions on 3 before I get to 4. Number 4, we have 3 logs here. Log base 2 of 5 plus log base 2 of x minus log base 2 of 10. So remember, we do 2 terms at a time, and we always go left to right. So do the first 2 first. I'm going to take these 2. We have a plus here, which means we actually just multiply. I'm going to condense those. Log base 2, 5 times x, that's just 5x. And then we bring down minus log base 2 of 10. And then we condense again. So we'll condense these 2. And reminder, this minus here is actually division. So I'm actually dividing those. Log base 2. And then we go left to right here. So 5x goes on the top, divided by the 10 goes on the bottom. Now, if you think we're done, we're not. Look at that again. These are monomials, or just one term each, no pluses or minuses. So we can reduce the 5 and the 10. If you need to use a calculator for that, obviously you can't type the x in, so if you're looking for that button, you won't find it. 1/2. So I'll rewrite that as log base 2 of 1x over 2. You can also just write x over 2 if you prefer. And then the parentheses aren't absolutely necessary, but if it helps you visually, especially to separate those 2's, then I would write those. But that's a personal choice. Questions on number 4 before we do the last 2 on the back? Okay. We're going to kick it up just a notch. Number 5. 5 log base 2 of x minus 2 log base 2 of y. Hopefully you notice the numbers in front of the logs. Those are exponents, and those must be done first. So remember, we place them in their new spot as exponents. Now this 2 here, it has a minus in front. You don't bring the negative with the 2. Just leave the negative and bring the 2. Place it in its new spot. Rewrite. We have log base 2 of x to the 5th minus log base 2 of y squared. Now that we've taken care of the exponents, we can actually condense. This minus we know is actually just division. So then we have log base 2. X to the 5th goes on top. Divided by y squared goes on bottom. And there's nothing else we can do with that. Can't cancel. If anything, if you want to put parentheses around it because it looks nicer, you can do that. And this is our answer. Questions on 5 before I do the last one. Number 6. Log of 5 plus 3 log of x minus 4 log of y. We notice that the base is missing. Let's remind ourselves. If we have no base, what is that base? 10. Now, you're more than welcome to write that 10 in there if you like, but you don't have to. As long as you understand it's a 10, I understand it's a 10, everyone else understands it's a 10, you don't need to write the 10 unless you want to. So, I'm not going to write it. I'll keep it blank. Very first thing we do is we move the exponents. We have 2 of them. The 3, I'm going to place it at the end of that log on the x where it goes. And the 4, place it at the end on the y where it goes. Rewrite. We have log of 5 plus log of x cubed minus log of y to the 4th. Now we can condense, again, 2 terms, 2 logs at a time. We'll start with the first 2. This is addition, so we're actually going to multiply those. Log, and then it's 5 times x cubed, so you just write all that together. 5x cubed minus log of y to the 4th. And then we condense. Minus turns into a divide. Well, this is a minus. We're going to divide, though. Log of 5x cubed will go on top. Over y to the 4th goes on bottom. And again, you can leave it like that. You can put parentheses around it if you prefer. That's our answer. Questions before we move on to calculator things? All right, I'm sure that you guys have been wondering how to use the calculator because if you look, you will notice there is a log button on the calculator. We can use the calculator to help us with the logs. So let me demonstrate what the issue is first before I show you how to do it. So say I try to type in number 7. log of 41. What's the glaring difference between what's written on my paper and what I typed into the calculator? Go ahead. There's no base. The base here is 3. What's the base in my calculator? 10. That's the problem. The calculator will always assume a base of 10. So there is a formula that we can use that will tell it we need a different base. That formula is called change of base formula. I'm going to write it out in letters, and then of course I will do these 6 examples showing you what it looks like. Log, and then I'm going to use the letters I used on the first day. Base A of C equals, and then here's the formula. Log of C over log of A. I have a couple tricks to help you remember this without memorizing the formula as it is. First little tip. The base always goes on the bottom. Base, bottom, bottom, base, both start with B's. Here's the other trick, and I quite like this one. So let's do number 7. Log base 3 of 41. If you remember our first day of logs, I spent some time talking about the proper way to write them. Make sure you have the numbers leveled out correctly and written correctly. So I drew a line under the log and the big number and kind of cut off the base to show you that the base should be lower. We can use that to our advantage here. Give the bottom a log, and now you see what the calculation should be. Log of 41 over log of 3. I'll write that out nicely. And that's how you do it. So log of 41. And parentheses are always advisable, especially with logs. So if your calculator does not automatically give you parentheses like mine does, please use parentheses. Divided by log of 3. And before I hit enter, we have some rounding instructions here. Round to the nearest hundredth if necessary. It will be necessary. Nearest hundredth, how many decimal places is that? 2 is correct. 2 decimal places. So we have 3.38, that's the second place. The next number is a 0, so we will not round up. 3.38 is our answer. Do that again. Number 8. Log base 25 of 75. I'm just going to use that trick. Draw a line under the log and the next number, 75. That means our calculation is log of 75 over log of 25. Don't forget to give the bottom a log as well. If you drop the log on the bottom, it will be wrong. For those of you wondering, the squiggly equal sign, this means I'm rounding my answer. The straight line equals means it's an exact number. Now, if you don't want to use this, that's fine. That's just how I do it. Log of 75 divided by log of 25. 1.34, the third number is a 1, so again, don't round up. 1.34. We round up if the next number is 5 or bigger. Questions on 7 and 8 before I go through the last 4? Okay, I'm going to go through these next four kind of quickly since it's the same thing over and over again. Now, when this is a fraction, this still works. I just got to cut it off a little differently to make it look the same, but it works out. Log of 5/3 over log of 12. And when you type in the fractions for the logs, use the ABC button, especially if you insist on not using parentheses. If you write the division sign without parentheses, it will read it very differently. Divided by, you must use a division symbol for the separating of the logs. Divided by log of 12. 0.20, the next number, the third number is a 5, so this will get bumped up to a 1. 0.21. Again, number 10. Log base 1/4 of 20. Log of 20 over log of a 4th. We'll just type that in. Log of a 4th, I'm using ABC for the 4th. I'll put an extra parenthesis, hang on. There we go. Negative 2.16, the third number 0 will not bump our 6 up. Now, sometimes you will get negative answers out of the log. That's okay. Remember, you just can't plug negatives into the log. That's the difference. Number 11, log base 5 and negative 3. So we have log of negative 3 over log of 5. And if you're paying attention, you should already know what this answer is without using the calculator. Again, as I've told you before, you can't plug negatives into the logs. This is what happens when you try to enter that into your calculator. So, I'm going to write down that message, domain error, but that's not my answer. Domain error means that you try to plug in a number that you can't plug in. It's not something you did wrong. It's just not something you can do. It's just not doable. So my final answer, there is no answer, so no solution. Last one, number 12. Log base 2/3 of 13. Log of 13 over log of 2/3. Oh. Negative 6 point, we have 3, 2, 5. This 5 will bump the 2 up to a 3. Negative 6.33. Any questions on change of base on the calculator? So a couple things. On these problems, you are expected to write out the work, especially on the homework, because the homework you have the answer, so you at least need to write out how you get to that answer. Write out the work for me, please. If you don't on the homework or on the test, you will lose a partial credit point, so 1 point. So it's not worth it. Write out the work. It only takes a moment. At this time too, there have been problems we've shown you where you could have used this, but we hadn't shown you yet. So on the test, there will be some problems that you would have solved a different way. Then now you can just use the calculator. You are absolutely allowed to do that. This is fair game now.